Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 5.5, parallel and perpendicular lines. So as always, we have a warm-up, and once again, I'm going to remind you that doing the warm-up ahead of time is much more beneficial to your learning than just copying the answers afterwards. Okay? So write the equation of a line that passes through the points 0, 3 and 6, 3 in slope-intercept form. So to put it in slope-intercept form, I need to know the slope. So I'll go ahead and calculate that. So my slope is going to be the change in the y's, which is 3 minus 3, over the change in the x's, which is 6 minus 0. So this will give me 0 over 6 or 0. So my slope is 0. So I'm going to write this in slope-intercept form. This is my y-intercept right here. So b is 3, because it's what is the value of y when x is 0. Okay, so I can write it in slope-intercept form now really quickly. Slope-intercept form is y equals mx plus b. So I have y equals 0 times x, but 0 times x is nothing, and then my b is 3. So this is actually a horizontal line. If I was to plot these points, I'm going to do it really fast here. Make a quick sketch of it. 0, 3 would be about right here, and then 6, 3 would be about here, and we'd have a horizontal line. All right, number 2. Find the slope of a linear function f that has the values f of 10 equal to 3 and f of 12 equal to 7. So this is really the input 10 makes the output 3. And this one here is really the input 12 makes the output 7. So we use these two ordered pairs to find our slope. So 7 minus 3 on top, 12 minus 10 on the bottom. This gives me 4 over 2 for 2. So my slope is 2. Number 3, write the equation of a line that passes through the points 8, 5 and has a slope of 3 in standard form. So standard form, remember, is ax plus by equals c. But there's no way for us to start in standard form, so we have to pick one of these other ways. Well, what information are we given? We're given a point, and we're given a slope. So the trick here would be to start in point slope form. So I'm going to do y minus 5 equals the slope times x minus 8. I got the x and the y coordinates, that's 8 and a 5 from here. So y minus the y coordinate and x minus the x coordinate. Okay, and then I'm just going to transform this until it gets into standard form. So I'll go ahead and start working on my transformation here. I'm going to distribute the 3. So this will give me y minus 5 equals 3x minus 24. And then I'm going to move the 5 over because the constant terms are all supposed to be on the right. So I'll get y equals 3x and negative 24 plus 5 is negative 19. And then I need to get the x onto the left side. So I'll subtract 3x to both sides. So I'll do negative 3x plus y equals negative 19. Now this is fine with me for an answer, but usually as convention they like to have positive value for the x. So if you're checking books or on a website, you'll probably see this instead. Just flipping all the signs around and making it positive 3x minus 1y equals 19. So remember our a, b, and c in this case could be a is 3, b is negative 1, and c is 19. Number 4, graph each equation and state its slope. So we're just practicing with these horizontal and vertical lines again. If you forget that that's what that is, remember always make a chart. We're trying to graph a line, not a single dot somewhere. So we're going to put y as negative 4, and x can be anything we want. So that's 0, negative 4, goes right here, 1, negative 4, 2, negative 4, and then I draw my line across. So this is our horizontal line, y equals negative 4. The other one works very similar. So x is always 3, and y can be anything we want. So we'll do 3, 3, 3, 2, 3, 1, and we can see that this is a vertical line this time. So this is x equal to 3. Now the second part said state the slope. So the slope of this one is 0, and the slope here, undefined. Vertical lines have an undefined slope. We don't have a number to say how steep that line is. All right, on to page 2. Okay, so this section was about parallel and perpendicular lines. So we learned about parallel lines in chapter 4. So we have a quick review here. Remember, two lines that are in the same plane are parallel if they never cross. And parallel lines have the same slope, but different y-intercepts. So they start at a different place, but they have the same steepness value. So let's graph these lines here and show why they're parallel. So the first one has a slope of 2 over 1 and a y-intercept of -3. The second one has the same slope, 2 over 1, but its y-intercept is -1. So the top one I'll graph in red. Okay, so the starting place is -3, and it has a slope of up 2 and right 1. So there's its steepness value. This is y equals 2x minus 3. And the bottom one I'm going to graph in blue. So we have a starting value at -1, and we go up 2 and over 1. And this one is y equals 2x minus 1. And you can see that these are parallel. They have the same steepness, but they start in different places, so they never cross. Okay, so what are the slopes of the lines above? They both have a slope of 2. So first line is 2, and the second line is 2. What are the y-intercepts of the line above, the lines above? So the first y-intercept is -3, and the second y-intercept is -1. Why are these two lines parallel? Let's see. They have the same slope, of 2, and different y-intercepts of -3 and -1. All right, something new here, perpendicular lines. So two lines in the same planes are perpendicular if they intersect to form a right angle. So they make a cross or a T, okay? Horizontal and vertical lines are perpendicular, okay? So if we have a horizontal line and we have a vertical line, those guys are all perpendicular. If two non-vertical lines in the same plane have slopes that are negative reciprocals, then the lines are perpendicular. So ignoring this special one, any other ones, these two slopes, slope for this one and the slope for line 2, are going to be perpendicular if they are negative reciprocals. And we'll talk about what that means in just a minute. So if two non-vertical lines in the same plane are perpendicular, then of course the reverse is also true. They're going to have negative reciprocals for their slopes. So given each slope in the table, write the slope of a line that's parallel and of one that's perpendicular. So we're going to go through do the parallel real fast. Parallel should be the same slope. Remember, same slope but different y-intercepts. So 2, 1/2, -4, 5/4, and 0.25 is fine. Perpendicular is supposed to have negative reciprocals. So the reciprocal of 2 is 1/2. You just take the fraction and flip it upside down. If it doesn't have a bottom, remember there's always a bottom of 1, and that's why 1 comes up to the top here. And we're supposed to have negative reciprocals, so our slope is going to be -1/2. And the second one, we have to flip it upside down to get the reciprocal, so that becomes +2, and then we take the negative of that, which makes it -2. And the third one, we flip our fraction upside down, so it becomes -4/5, and then we take the opposite of it, the negative of that, which makes +4/5. And then in our last one, we don't have a fraction, but it's just written as a decimal, so let's just change this real fast to a fraction. It's 1/4. Flip that fraction upside down, it becomes 4, and it was positive, so we change it to negative. Okay? So notice for parallel versus perpendicular slopes, always opposite signs. So on our first line, we have a positive and a negative and a positive on the second one, a negative and a positive on the third one, and a positive and a negative on the fourth one. They're opposite signs. If one's positive, the other's negative. Okay? And then also, all the fractions are flipped upside down. That's what makes it be perpendicular. Okay, on to page 3. Number 2, write an equation of a line that passes through negative 3, 3 and is parallel to the line y equals negative 2x plus 1. So if I know the two lines are parallel, I know a slope for my new line. My slope is going to be the same slope as this line, so it's going to have negative 2. And now I have a point and a slope. What's the easiest way to write an equation with point slope? Well, we'll write it in point slope form. Doesn't tell us what way to write it, so we're going to do y minus the y coordinate, and then the slope, and then our x coordinate was negative, so it's x minus a negative 3, but we write that as x plus 3. Get rid of the double sign. Okay? If it doesn't tell you what form of the line to write it in the easiest form possible. Okay? A lot of times, though, if you look in a book, they're always going to give you the slope-intercept form, so they might have solved for y. So we'll do this really, click on this side. So they might have done y minus 3 equals negative 2x minus 6, and then added 3 to both sides. Now, I don't care which form you use. Use the one that's easiest, is what my suggestion to you. All right, write an equation of a line that passes through 4, negative 2, and is perpendicular to the line y equals 4x plus 2. So once again, I know the slope of my new line. It's going to be the opposite reciprocal of this slope. So if this slope is 4, my new one is going to be negative 1/4. Okay? And then we're going to put this in slope-intercept form. So we're told what form to put it in this time. But right now, all I know is a slope and a point. So the easiest way for me to start is to go ahead and plug in the things I know. And this time I'm going to use the old way from section 2. And I'm going to put in my y as negative 2. I'm going to put in my slope as negative 1/4. I'm going to put in my x as 4. And I get b here. And then I'll solve for b. So this will be negative 2 equals negative 1 plus b. And that makes b be negative 1. Add 1 to both sides. So my equation in slope-intercept form, which is y equals mx plus b form, is going to be y equals negative 1/4 x minus 1. Right, number 4. Are the lines 2y plus x equal negative 12 and 2y equal to 3x minus 8 perpendicular? Now the only way to tell this is to find their slopes and see if they're the opposite reciprocals. So we'll find the slope over here by solving for y. I'm going to subtract x from both sides to start with. Oops, that'll be minus x. And I should probably put the minus x in the front. And then I'll divide by 2, and I'm going to get negative 1/2 x minus 6. So I know my first slope. And now I want the other slope to be positive 2. And then I know that they are perpendicular. And that's because negative 1/2 and positive 2 are opposite reciprocals. So here, for the blue one, it's a bit easier to solve for. All I have to do is divide both sides by 2. And I'll get 3/2 x minus 4. So this slope is 3/2. These are not opposite reciprocals. So the lines are not parallel. The slopes are not opposite reciprocals. Okay. All right, last one. Write an equation of a line that passes through the point 4, 3 and is perpendicular to the line y equals 4x minus 7. And we want this in point slope form, which is the easiest form for this question. So here's our current slope. Our slope for our line is going to be the opposite reciprocal. So I'm going to make it negative because that one was positive. And the reciprocal of 4 is 1/4. So there's the slope I want. And now I'm just going to do y minus the y coordinate of the point that we have, which is 3, equals our slope we want, and then x minus the x coordinate of our point, which is 4. And then we are done. Okay? Because we have it in point slope form, which is what they asked for. Now you need to really know the names of the forms. So there's 3 of them. We have slope intercept, point slope, and standard. And you need to be able to change from one to the other and back again. All right, I really suggest you begin this Khan Academy coach's recommendation on equations of parallel and perpendicular lines. This is once again due the morning after our next class, but I suggest you get started on it. And if you're having a lot of trouble, then you know I didn't learn anything from watching the video notes. I need to go back and watch them again. All right, I'll see you in class next time.